Hello, let us talk about the process of making hydraulic hoses today. Hydraulic hoses are applicable in fields such as construction machinery, mining, metallurgy and forging, agriculture machinery, marine engineering. The rubber composite materials are mixed according to proprietary formulas. The steel is braided in multiple layers to withstand extreme loads. The entire structure is extruded and vulcanized under strictly controlled conditions. Even a small deviation could cause a hydraulic system worth millions of dollars to become unstable. The hydraulic hose market generates over several billion dollars in revenue annually. There are over 1 billion feet of hoses in use worldwide, silently supporting various fields ranging from construction machinery to aerospace and defense. Hydraulic hoses are not merely made of rubber. Instead, they have an internal multi-layer reinforced structure that combines rubber with steel wires or fiberglass, polyester fibers, etc. to withstand extreme pressure. The soft rubber hose has been transformed into a hydraulic hose capable of withstanding the actual working pressure. And the core of this transformation lies in the addition of steel wires. The hose is sent into the wire winding machine or the braiding machine, where high-strength steel wires are spiraled around the pipe at precisely calculated angles. This winding angle determines the reaction of the hose when the pressure rises, compact enough to prevent radial expansion, while also balanced to maintain flexible during bending and usage. The speed of our steel wire braiding machine can reach several dozen revolutions per minute. Therefore, a braiding machine can produce thousands of feet of reinforced rubber hoses. However, excessive tension may cause the rubber core to deform, while insufficient tension will prevent the steel wire from fully bearing the load when the pressure increases. After the steel wire reinforcement was completed, the hydraulic hose has formed a fully developed load-bearing structure. The internal pressure no longer acts on the rubber. Instead, it reappears as tension and is distributed over the surrounding steel wires. Subsequently, an external rubber layer will be applied to the hydraulic hose to protect the entire structure. The hose is coated with rubber through a continuous covering system around the reinforcing material. The line speed is synchronized with the extrusion pressure to ensure uniform thickness of outer layer throughout the entire length of the hose. At this point, the hose has reached its final shape. However, the material layer hasn't yet been bonded. An outer rubber protective sleeve is needed as the final barrier of protection.